Welcome to Helion Talks. I'm joined today by a distinguished, now retired flight test engineer, civilian pilot and author Bill Norton, who's here to discuss the first volume of his remarkable new series on the 80-year history of air-to-air missiles. Bill, it's great to have you with us. And to start, could you perhaps tell our listeners and me a little bit about yourself?
Of course. As you noted, I'm a retired engineer. I was actually an Air Force officer, U.S. Air Force, for 20 years and continued working in the field of aeronautical engineering, where I have a graduate degree, and principally in flight test engineering. So that brought me into contact with missiles and particularly air-to-air missiles on many occasions. And of course, my flying gives me additional insight into the aeronautical aspects of air-to-air missiles.
And I think it naturally leads to that. Is this what drew you to this topic initially?
Well, I was actually one of the principal Helion editors of the At War series, where this volume falls. His name is Tom Cooper. He suggested it when I said I was casting about for the next writing project. And it appealed to me, the idea being that I could bring my engineering background, my knowledge and my experience into explaining the technical aspects. And of course, I've been writing about aviation history for many years. So I'd also be talking about how these would be shielded and operated by air forces or air arms around the world, where I also had experience. So it appealed to me from that perspective. It's also possible that those skills that I bring to it can improve upon publications that have been existing on bookshelves for decades and nothing new has emerged. So I'm hopefully going to contribute substantially to that literature.
I certainly think it does contribute to that broader literature. And for myself and for other listeners who's maybe not as advanced in the field, could we start with the basics? What makes an air-to-air missile work? If you could give us a breakdown just of some of the main components for us, a general audience.
Yes, of course. So it is a weapon carried on a combat aircraft rather than the more classical cannon or gun. This is a guided weapon. And so it's launched off of an aircraft, either off of the wing, fuselage, or internal weapons bay. It has its own propulsion system, guidance system, and seeker. So at the front of each of these is the seeker head, which works to detect the target before launch and then during flight. And it does this by a variety of means, most classically infrared detection and radar detection. The output of the seeker head goes to a guidance section, which determines the best means of intercepting the target. And those signals are then sent to a control section, which operates the control surfaces on the missile, such as rudders and ailerons that we have on plastic aircraft. And the intent is to get it very close, if not impact the target. Generally, impact is very rare. So you would have a proximity fuse of some manner, which would detect close passage to the target, and then that would detonate the warhead, which is another section. And finally, there's a motor. Most classically, this is a solid propellant motor that's ignited and pushes the missile off of the aircraft and then accelerates it to very high speed and will burn out at some point. And most of the flight from that point, most of the flight of the missile is unpowered. It is coasting. So those are the breakdowns. And of course, the first book in this volume, in this series, will go into detail on all of these.
It is interesting. And as you explained that, it kind of made sense, the way that it was powered, although I probably do need to read up quite a bit more. My follow-up to that is a little bit cheeky, but why do so many missiles miss? And what are the challenges of hitting a moving target, and especially in combat?
Well, that's a very complex topic. And I have a table in the book, and I go to great lengths to try to explain that, because in later volumes, I attempt to outline every engagement, air-to-air engagement that has occurred that has used air-to-air missiles from the very beginning, which is in the 1950s by the Taiwanese, to the present day. And so you'll see there that there's a great many that miss. One of them is still aircrew proficiency. A lot of times these pilots, when they fire the missile, it's the first time they've ever done it, and sometimes they're surprised. And then in the heat of battle, sometimes they will not set up the shot properly and put the missile at a disadvantage from the beginning. They also have to detect the target, and that's normally by the radar on the aircraft or an infrared detection system. So you have to be able to detect the target and ensure that you're within range and optimal conditions or close to ideal conditions for the missile to succeed. And then there's the aircraft capabilities. So even the launch aircraft may have to maneuver to set up a shot that has high potential for success, while the target aircraft, that pilot is maneuvering to try to spoil the shot and ensure they don't get killed. So aircraft capability still plays a role. Then there's the scenario of the shot, so the range, the speed of the engagement. So the missile has a speed, but so does the target. The target may succeed in outrunning the missile. The aspect of the shot, for example, tail on or nose on or side on and everything in between, those have a big role to play in the success for the engagement. There's the environment for the shot. For example, weather still plays a role. And then there may be countermeasures being employed by the target. And then the missile itself may have countermeasures. The reliability of the air-to-air missile, these are complex and they don't always work properly. In many occasions, they are decades old and you're expecting them to work perfectly. That's not realistic. So ideally, probably on average, expect, well, these days they're very reliable, but in the past, 80% was very high reliability. There's also the unexpected and the intangibles that fall from all of those that I described already that can play a role in whether you're going to strike the target or the missile will fail or the target evades the missile.
That makes sense. And you mentioned the human factors also, and that kind of resonates, I think, throughout every kind of warfare, the overused idea of friction and how that plays out. And I suppose with this, just thinking about it, there's literally so many moving parts in it.
Yes, an engagement not only has the aircrew in both aircraft, but the systems on both aircraft and then the missile itself. And all of these tend to be very highly integrated in common aircraft we're operating today. So there's lots of places where things can fail.
Bill, you mentioned some of the missiles being decades old. And could you maybe talk to us a little bit about generations, I'm doing it in air quotes for our listeners, generations of missiles and how they've evolved over time, perhaps from the Second World War up until the present day?
Oh, certainly. So we were already talking about the complexity of things, the environment, the aspect, the electronic warfare environment, reliability. So all of those you seek to optimize through technology, and technology has advanced considerably since the Second World War. There's also mission needs. So we started flying airplanes supersonically, expected to launch missiles supersonically, target aircraft maneuvering at higher G loads or rates, turn rates. And so we needed a missile that could still successfully intercept those. We also wanted to engage them at higher ranges or greater ranges such that any shots that they let off is going to fall short so that you can fire your missile. And then we talked about the electronic warfare environment, which has grown more and more complex. So all of those things are the technology based. There's also the impetus of the air war itself, the rules of engagement that are applied, the requirements, drive requirements for the missiles. So we want to be able to place missiles inside the aircraft in a weapons bay to make the airplane stealthy, just as an example. So that will drive changes to the missile, and certainly early generations didn't have that capability. Then there's cost. cost has continued to increase. For example, one of the very earliest missiles, the Sidewinder, the very first model of Sidewinder that was deployed cost approximately $6,000. The ones that are operating today cost approximately $500,000. So we want to make sure that they operate properly. And there's just so many that we can buy, so many that can be carried. And then service life. If we're going to spend that much on a weapon, we want to make sure it can be on the shelf and ready to be deployed over decades. So as you mentioned, World War II or the Second World War, Germans had an air-to-air missile that was interesting. It wasn't probably very effective. They got very far along in the testing, but it was near the end of the war and it was never fielded. The Americans and the British also had some systems. They were very immature. Those are not considered first generation. I call it the zeroth generation. And then immediate post-war was the first generation. And those were very immature technologies, very low reliability. And then the Cold War drove a great deal of technological advancement and requirements changes. So I've broken that down into generation 2, 3, and 4, or early Cold War, mid, and then late Cold War. Generation 5 are what are in most aircraft these days. They're post-Cold War systems. And then Generation 6 systems, there's a few of those that have been fielded just very recently, and many more that are in development. So 6 generations, not counting the zeroth generation.
That is interesting. And I hope you'll forgive me for this one, but for the layperson who's followed, and a little bit tongue-in-cheek, but has followed Top Gun in the late 80s and the most recent Top Gun, how close do they come to the science that you studied and that you bring in your book, Bill?
It's presented very superficially. The pilots, the aircrew members, which might include a guy in back, we call it a GIB, or a weapons officer. There's a lot going on to try to ensure success of the shot. They're already going into combat aware of the environment that they're fighting in, particularly the electronic warfare environment, and then the targets or the enemy aircraft they're likely to engage. So they're already thinking about what's the ideal setup they can do to fire their missile. And then there's a lot going on in the cockpit, indications to let you know that you're in the best firing box or that you may have low reliability of an intercept, and then telling you the status of the missile. So from the moment you push the button to fire the missile, there's a lot going on, and maybe a second before it actually leaves the aircraft. And that, of course, isn't very dramatic in a movie. So they simplified it considerably for dramatic purposes.
Absolutely. And I think it's always the boring elements, if I can call it like that, science, the administration, the logistics, and the science. I think that makes the real military work in real life. And I suppose afterwards it's the battle of biographies and the battle of movies and so on, right? That come the narrative.
And military history writers such as myself.
100%. And thank goodness for this book. I'm just wondering, as you've spoken through those different generational missiles and some of the details around this process, I mean, a thought that I'm sure many listeners have is that this is most likely for a conventional war, like between peers, right? And our experience up until recently was maybe more counterinsurgency or limited or low intensity warfare. I'm not sure how keenly you are watching and observing the current conflicts in Ukraine, for example.
I am, and also the Arab-Israeli conflict. So one of the challenges these days are shooting down drones. So drones may cost $10,000 or a few tens of thousands of dollars. And so you may engage it with an air-to-air missile that costs $500,000 or $1 million. And you have just so many of those. There are a great many drones that can be sent into the airspace, hundreds of them. The intent of the adversary is to swamp the defenses. And so you send out your interceptors, and of course, there's ground-based surface-to-air systems as well. But for an air-to-air engagement, it becomes very challenging to shoot down all of those. So there's actually work underway today and some systems that had been deployed to use much less expensive systems. Well, many more of them can be carried on an aircraft. So, for example, a 2.5-inch diameter rocket with a laser seeker head. And so the shooting aircraft would place a laser designator on the drone and then fire this very inexpensive missile, a few $1,000s, and has high probability of shooting down the drone. So those are some of the challenges that we're experiencing right now.
Yeah, it does feel, and I'm just saying it as as an observer and just someone that's watching and, with open source intelligence, nothing detailed, but one does pick that up about the swarming effect and the idea of even dummy drones, hundreds of them being sent in. And when you bring that economic aspect, it does bring it home, Bill.
Yeah, this business is very costly, and there's just so many people that can play in this game. There are just about every country has an air force, but some of them are operating very outdated systems with not much hope that they're going to work properly. Depending upon who their adversary is, it may be that they're just completely outclassed, and there's no point in even launching the aircraft off the ground.
That does feel, just this kind of the balance of power with those that invest in their militaries and the tech, which is so fast evolving. And, and on this, could you perhaps tell us a bit about, you've mentioned it earlier, but just a little bit about this series, which is just fascinating.
Yes, there's 6 volumes in this book. And the first one, which we've been talking about, which is just in release, can be ordered now from Helion, talks about the technology and how it would be used in service and all of the factors that play in that. And then that is built upon in the subsequent volumes. So volume 2 talks about that, the Second World War, 0th generation, and then the first generation. So prior to the Cold War. And then there's a volume on the 2nd generation, 3rd generation, 4th generation. And the 5th volume, which talks about the 4th generation, also talks about helicopter launched air-to-air missiles. And then the final or 6th volume talks about not only the 5th generation and the emerging 6th generation of air-to-air missiles, but also has a chapter on anti-missile missiles, so air-launched missiles intended to hit other missiles, particularly ballistic missiles, and also to hit satellites in low Earth orbit. And all of these volumes have a chapter on the combat of the period that used these systems and how effective they were, how successful they were, and gives you a summary of hopefully every engagement that was performed. Most of the time, all you're hearing about are the ones that were successful, but I hopefully captured everything that's out there about the shots that did not succeed as well.
Absolutely fascinating, Bill. And, it's something that, as someone that's very much into military history too, and also once served, it's something that I've never really thought about in that much detail. And it's definitely something that I hope our listeners have found fascinating too. All that we can say is a big thank you. We will add the links into the show notes, and we look forward to getting some interesting comments from our listeners, which we will, of course, forward on to you.
Excellent. Happy to do it.